Welcome to The Explainer. Today, we're going to talk about something that's, well, it's everywhere. It's this invisible architecture that shapes our entire world, from the wild, chaotic spin of a hurricane all the way down to the water just flowing out of your tap.
So let me just start by asking you a question. What in the world does a monster hurricane like this one, the flight of a simple golf ball, and yeah, the water from your kitchen sink all have in common?
The answer? They all play by the exact same set of rules. It's a field of physics called fluid mechanics, and it's basically the hidden blueprint for how every liquid and gas on the planet behaves.
Okay, so to really wrap our heads around this, let's start with the absolute basics. What happens when a fluid isn't even moving? This is the world of hydrostatics.
The key idea here is pressure. And you already know what this feels like, right? Just imagine jumping into the deep end of a pool. That feeling of the water pushing on you, that's hydrostatic pressure. It's literally just the weight of all the water above you pressing down.
Now this simple idea, it actually explains why things float. And we can see just how powerful it is when we look at something truly massive, like a giant iceberg.
Now get this. Our source material points out that for a typical iceberg, which is made of frozen fresh water floating in denser salt water, a staggering 7/8 of its entire mass is hiding under the surface.
I mean, just let that sink in for a second. We're talking about a mountain of ice weighing millions of tons just floating there in perfect equilibrium. The massive downward pull of its own weight is being matched perfectly by the upward push of the water it's sitting in. It's an incredibly simple principle, but wow, is it powerful.
Okay, so that's when things are calm. But what happens when we set things in motion? Well, that's when fluid mechanics gets really interesting and honestly, a little weird.
And this is just a perfect illustration of the two sides of fluid dynamics. On the left, you see this absolutely beautiful, elegant spiral pattern created by a marine propeller spinning in the water. It's like art. But on the right, you see the harsh reality. The exact same process has literally chewed up and eroded the solid metal of another propeller.
So, how is that possible? It seems like a total contradiction, right? How can plain old water be both a graceful artist and a brutal destroyer, all at the same time?
The secret is this really wild process called cavitation. You see, as that propeller whips around at high speed, it creates these tiny zones of super low pressure. The pressure drops so much, so fast, that the water right next to the blade actually starts to boil, even though it's not hot, and forms little bubbles of water vapor.
But here's where the damage comes in. A split second later, as those bubbles move into an area with normal pressure, they collapse. And when I say collapse, I mean they implode violently. Each collapse creates a tiny, focused shockwave, like a microscopic hammer blow. Now imagine millions of those little hammers hitting the metal over and over. They act like a sandblaster, tearing the surface apart.
And this just goes to show you how mind-bendingly complex this stuff can be. I mean, our source material even warns that some of the core formulas are a dangerously restricted relation that gets misused by both students and graduate engineers. It's a field where you really have to know what you're doing.
Okay, so if these fluid forces are so powerful and tricky, how on earth do we build things that can survive, or even better, work with them instead of against them?
You know, have you ever stopped to wonder why airplanes, high-speed trains, and even birds all have that similar sleek shape? It's not a coincidence. It's all about mastering the art of moving through a fluid.
Just look at this table. It's all about how much resistance or drag different shapes create. A flat plate hitting the wind head-on, yeah, that's got a ton of drag. A sphere is better, but a streamlined shape like an airfoil, whoa. We're talking less than 1/10 of the drag of that flat plate. That is a massive, massive difference. And that right there, that's the magic word, streamlining. It's all about shaping an object in a way that encourages the air or water to flow smoothly around it without getting all turbulent and messy. When you nail that, you minimize drag, and that means you get incredible efficiency. It's true for a bird on a long flight, and it's true for an engineer designing a new car.
All right, so we've seen how fluids behave and how we can design things to move through them. Now for the really cool part, how do we harness all that incredible power for ourselves?
Well, take a wind turbine. Those massive blades, they're basically just giant spinning airfoils. They're shaped with those exact same principles of lift and drag we just talked about, all to perfectly convert the raw energy of the moving wind into electricity.
And it's the same story with water. This thing here is a Francis turbine used in big hydroelectric dams. And just look at it. It's this incredibly complex maze of blades and channels. Every single curve is engineered with fluid mechanics in mind, all to grab the immense power of flowing water and turn it into energy.
And that's really the big payoff, isn't it? By cracking the code of this invisible architecture, by understanding pressure, flow, and drag, we can engineer these amazing systems that literally power our entire modern world.
So when you boil it all down, it really comes back to these three big ideas. You've got pressure, the simple weight of a fluid just sitting there. You've got flow, the beautiful but sometimes destructive power of that fluid when it moves. And finally, you have interaction, the dance between an object's shape and that flow. These are the building blocks to seeing that invisible architecture all around you.
So, now that you know the code, I challenge you. Look around today. From the way the wind blows through the trees to the steam curling up from your coffee, see if you can spot that invisible architecture doing its thing.